Hi, welcome to another lecture of In the Cosmos Redshift. Previously, we have discussed about the vectors, the basics of the vectors, the ideas of the vectors, and the algebraic computations of the vector. In our previous lecture, exactly, we have discussed about the vector differential operator. I think the Dale operator, Nabla operator, whatever you say, and the gradient. We have also seen how gradient can gives you the vectors, how from a scalar field, how gradient can gives you the wind map from atmospheric pressure maps, right? In that here, what we'll understand from the divergence will give you, in a vector it will give some informative scalar number, like in a box some fluid is inserting in insiding the box, and some of the fluid are outsiding the box. The divergence can tell you that whether this box is sourcing of the fluid or the sinking of the fluid. If the amount of fluid is less outside, getting outside is less than of the getting inside, then it is certainly a source, some fluid are creating inside the box. And if not, then another, I think if the sourcing is high, means more fluid is inserting but less is getting out, then you can say that some of the fluid is getting sink in that box. This is the idea of the physical intuition of the divergence. Now, what is the difference between divergence and gradient? We have already told the gradient will gives you a scalar field to a vector. So if you input a scalar field into the gradient, like a temperature map or like a atmospheric pressure map, it will give some vector like a wind map or some, that's all. And what in the divergence, if you put a vector, it gives you a scalar. Like if you put a box that how much it is flow, outward flow, and how much inward flow, it will gives you a number, that whether it is a positive number, that that much is getting out from that box. So divergence is something, a tool that can change a vector into a scalar, right? Now, how can we mathematically define the divergence? We have defined the Dale operator in previously, and this is our Dale operator. Our del operator, del x ex, del plus del y ey plus del z ez. Now we can define that our divergence as a dot product of del operator and that particular vector. Now let's, the particular vector is ax ex cap plus ay cap uy cap plus az uz cap. Then we can, from, if we do a dot product, we can understand, we can recall our dot product. So that will gives you del x plus del y plus del z, that will be our divergent. Okay. Now what if your normal position vector, just r is equal to x e x cap plus y cap z cap, what will be the divergent of this? The divergent will, the first thing is the you will have to find the divergent of this del r. Okay, now del r will be divergent of del x ex cap plus del y uy cap plus del z ez cap into dot product of x ex cap plus y uy cap plus z ez cap, right? Now what will happen in the dot product? Only the same unit vector along, the same unit vector along will be exist, and rest of the are eliminated. Well, so what will be del x, so the final will be our del of del x x plus del of del y plus del of del z z. Now it is 1 1 and 1. We know from our simple vector, simple differentiation, that del of that is. So finally what will be there? 1 plus 1 plus 1, that will be 3. So that will expand a uniform physical field has a constant positive divergence, right? Now how divergence means. If the divergence gives you the value of positive, that means if divergence is greater than 0, then that means it is source. So the outflow is outward from the center. Okay, and if it is less than 0, then it is sinking. So the output flow will be downward inside the inside the box actually. That is divergence, negatively divergence, or divergence less than 0. And what happened when the your divergence is 0, then that means the no nothing, neither it is source nor it is sinking. That means no fluid is inside getting vanishing, or no fluid is creating as well. So that will tells you the divergence. The fluid comes to the box, that same fluid out from the box, that is the divergence 0 does means this. Okay, now another important concept is central force field. Okay, what is central force field? Central force field is a spatial field where the force extent is always directed toward or away from a single point, and this magnitude only depends on the distance of r from the origin. So if that magnitude only depends on the distance on the r, so we can consider this force is some kind of function that only depend on this distance r. Okay, and the direction of this will be along with this unit vector. Now we have to, now next target is our, we have to find the divergence of this general, this is the definition of general central force field. So we have to find the divergence of the general force field. How we can find? The first thing is we have to put it in our knowing format of vectors. So how we can do it? We can write this r as vector r by r, as a unit vector is, and this r is, we can write this r as, this vector r as x e x cap plus y e y cap plus z e z cap, right? So what finally we got, that we have to find the divergence of fr vector by r. That means we have to find the divergence of fr. This is the mod of r, x ex plus y ey plus z ez. Okay, we have to find that divergence. Now let's see the find the divergence of this, divergence of f of fr by r, x ex cap plus y uy cap plus z ez cap, right? We have to find this divergent. How we can find the divergent? Does means del of del x ex plus del of del y uy plus del of del z ez, and dot product with your this term, and x, or you can write that fr r x ex cap plus fr by r y e y cap plus fr by r z ez cap, right? Now this is your entire the divergence of the central force field. Now let's, what for first component, what we will see, that del of del x fr r x plus del of del y fr by r plus del of del z fr by r. Okay, now let's only forget about the rest of the terms and only consider these terms. Okay, how we, what we have is del of del x x fr. Let's first calculate this part, then we'll calculate the y component and the z component as well. But let's start with that the first part is this. How we can calculate this? We can think of let fr by r as a gr. So we what will get del of del x x into gr. Okay, that means that will gives you what gr plus product, the derivation product rule. You can use the derivation product rule and you'll get this x g prime r. Okay, now we don't know the we know the value of gr, but we don't value we don't know the value of g prime r. Let's find the value of g prime r. Okay, g prime r. How, what is the g prime r? G r is equal to fr by fr. We can use the quotient law, and also you can use the product law as well. Just think of that r is equal to r to the power minus 1. This terms are, this r is equal to not, this terms will be just we'll do fr into r to the power minus 1. In that way you can use that your product rule as well. I usually don't use the quotient rules. I always use the product rule by in that way. So how we what will be there? The g prime r will be fr by the first thing is, the first thing first, fr will be in the first component, let fr will be as it is, and sorry, fr will do the derivative of the fr and r will take keep as it is. We are doing that respect to x, so we have to add this minus of fr by r square dr dx. Now from our previous lesson we know dr dx will give you that x by r, dr dy will give you the y by r, these all. Well, now now again come to our main topics, that this can now written as gr, that means fr by r plus x into f prime r r dr dx, sorry, minus f r r square and again dr dx. Okay, okay, now let's go to there. Okay, what we have seen, this fr by r plus x into this entire thing, and we can simplify it a little more, that fr by r plus x into x into f prime r by r. Now dr dx we can write it as a x by r minus of fr by r square, minus of f r by r square x by r. Okay, now we have seen this. Now we can more, what we can do, we can do more simplification of this, or we can take one thing, so we can x by r, we can fr by r plus, you can do it f prime r into x square by r square minus of fr into x square by r cube. Okay, and now we can take this fr by r alone, so fr by r, if we take it alone, then it will be 1 minus what, x square by r square. Okay, 1 minus x square by r square plus of this, this will be this. So for from the, if we find the derivative of this x component of this things, the x, this will gives you this 1 minus x fr by r, 1 minus x square by r square plus 1 that. Okay, now the same way it will gives you the, for the y coordinate it will gives you fr by r 1 minus y square by r square here. Is it r square? Yes. Y square plus f prime r into x square by r square. F prime r into x square by r square. Here y square by r square. And the, for the z component, same way you can see that if fr by r 1 minus z square by r square plus fr z square by r square. Now if we add, now if you find, try to find really the divergent of this point, the divergent of this central force field fr, or then what will be, we have to add all these three component, and if you add all these three component, what we'll see, let's find this divergent of this all. So the add all these three component, all these three component will be look like this. You can take this common fr by r, and then 1 minus x square by r square plus 1 minus y square by r square, plus 1 minus this z square by r square, z square by r square, uh, these entire things plus this x square by r square plus y square by r square plus z square by r square. Okay, now if you see this, that is 3 f r by r. Now it is 3 minus x square plus y square, x square plus y square plus z square by r square. That also means x square plus y square plus z square also means it is r square. So that is plus f r, that is this terms also gives you that x square plus y square plus z square by r square, that means 1. So this is, so in that way we get our divergence as equal to 2 is 2 into fr by r plus f prime r, what we have seen actually. Okay, it is our divergence of central force field. Now some interesting scenario in come, if your that if we are doing the r to the power n special case. Why this r to the power n special case? Because you'll see lot of the in scenario you can use this. So what it is that our this time our fr is the r to the power n. Okay, now what was our derived formula for the central force field is 2 f r by r plus prime r. It is, yes, it is. Now what into the r to the power n, if you plug this f r to the power n instead of f r, then we'll see that yeah, r to the power r 2 into r to the power n by r plus yeah, d of dr r to the power n. So it will gives you 2 into 2 into r to the power n, this is not a square, n minus 1, okay, plus n into r to the power n minus 1. So that gives you n plus 2 into r to the power n minus 1. Okay, so if you see that things, then you will get the divergent of this as equal to r to the power n along with that r unit vector. You will see that divergence. Okay, now we can apply this divergence into some another point. Like you can apply this divergence if you have electric field. You can see of the electric field. Electric field is our q by r square. Okay, now we can, if you put the value of n here, r2 is 1 by r square, that means the value of r n is equal to minus 2. If you and apply the rule what you have learned, you can see that the divergence of electric field is 0. And what does it means? That means that electric field is incompressible from a point charge. Electric field is incompressible in empty space. This is solenoidal, neither it is sinking, neither it is sourcing. And if you see the Hooke's law, that state that spring, the motion of the spring, like Hooke's law, it will tells you F is equal to minus kr, and the value as n, so value of n is equal to here 1. So we can apply the our knowing that rules, that is if that is rules we have just learned about the central force field, that, and then we can find the divergence, that will be minus 3k. It is a huge massive sink. That means it is a massive sink. Thank you so much for our listening. For your study material, please visit our website. We have put our description link below.
वीडियोस बनाने हैं, फिल्मोरा है ना।